Today I'm going to talk about preliminary results we have on one of the units that conform a metamorphic complex at the core of the Sierra Madre Oriental in northeastern Mexico. So I am an academic and a researcher at the University of San Luis Potosí in Mexico. And well, we can see here a map of the country where we can see many of the structures, but we can focus on this one, which is the Sierra Madre Oriental. And this is an orogeny, which at its basement is conformed by several units that I'm going to talk later, but we can see some of the distribution of the other older rocks in Mexico, which are of Mesoproterozoic here at the Sonora states and Chihuahua also. And also we have Paleoproterozoic rocks in the Oaxaca, the southern Mexico, as well as Paleozoic rocks. But here at the heart of the Sierra Madre Oriental, we have small outcrops of Paleozoic and Paleoproterozoic rocks. So in Mexico, it's conformed by several tectonostratigraphic terranes, and each of these has its own history and its own basement history. But we are located more or less in this zone, which is considered that most of the history of this zone is related to Gondwana, but in previous times, it was related to the Laurentian or the continuation of the Ouachita Marathon orogeny. So here we can see a picture of the Sierra Madre Oriental at the most beautiful outcrops we can find through the whole Sierra. And this is a physiographic unit with more than 800 kilometers length, and it's the product of the uplift and the formation of the Mesozoic rocks, including also the metamorphic basement during the Laramitic orogeny. So the studied area is located at least in three main outcrops. The biggest one, it's located here at the state of Tamaulipas, near to the capital city. And it's conformed by an anticlinorium with an eroded core. And there we can see the Paleoproterozoic and the Paleozoic rocks. So the Granjeno Schist is a Paleozoic unit, and it's outcropping in several canyons. So the basement units, I'm going to just give you a smart notice about them. It's the Novillo Gneiss, which is comprised by granitic gneisses, auger gneisses, and an orthositic mangerite charnockite series. And it has an age of 1.0 gigayears, and it's 780 to almost 9.20 kilobar on its metamorphism in the granulite and fibrolite-facies. All the structures are all the units are in structural contact. So the Granjeno Schist is in tectonic contact with a tonalite, which has an intrusion age of 354 million years. And we can see in the tonalite some xenolites of the same schist. It is also in tectonic contact with the previous unit, which is the Novillo Gneiss. And this is the Granjeno Schist metamorphic complex. It has many different lithologies. We can separate in two at least, an igneous, which consists of metapiloladas, metabasalts, and also an ultramafic unit composed by serpentinites and talc units. And a sedimentary unit, which is composed by pelitic, samites, metaconglomerates, metaturbidites, and graphitic schist. So we have studied most of the previous units, but there is not much about the graphite. So I'm starting to studying this subunit. And also in tectonic contact, we have a sedimentary sequence, which is not metamorphized, it's only deformed. And there we can find some conglomerates and some turbidites and paleochannels, which are from Silurian to Permian age. So the studied area, we can see several different types of the graphite. We can identify graphite, which is most pure, and also here is in tectonic contact with the serpentinitic unit, but also is intercalated with the pelites and the samites. And for example, here we can see that it's quite deformed. It even records the most of the deformation of the unit, and most of the times is together with quartz veins. Here also we can see a nice image of how the deformation is affecting this unit. So we have performed many studies on the previous units. We know that the metaigneous rocks are morph of origin, and the serpentinites are also morph and have subduction signatures. And recently we have also known about the metasedimentary units, which has a long period of deposition. And here is just an example of some microprobe analysis, and we can see that the graphite can be found at the porphyroblast and also at the lipidoblastic textures. And the mineral assemblage for the metasedimentary units and also for those which contain the graphitic schists are dominated by albite, chlorite, muscovite, and also tourmaline. So here we have some preliminary results about the Raman studies. We can see that the graphite, it's most of the time intercalated with muscovite or even inside the porphyroblast, creating these nice structures. And also we can see it intercalated with the quartz and in contact with them. So we have here an example of one of the spectra, and if we compare these spectra with other examples, we can say that at least we have an spectra representative of the evolution from green schist facies to blue schist facies. We have found at the metavolcanic rocks some ribichites, which indicate us that at least we have a transition between these grades. And according to the radius of the intensities and the areas of the spectra, we can see at least two groups of the temperature ranges, which goes more or less from 300 to 400 degrees. And according to the thermometer proposed by BESAC, based on the graphite, we can say that the maximum temperature that the Granjeno Schist could reach is 430 degrees. And well, at the minimum at this point is 318. It is quite important to us to understand the graphite, because it's just like a good indicator of the maximum temperature we can reach. As you can see, most of the mineral assemblage are not so helpful sometimes because we have no garnets, regardless they were described, but we have made a lot of studies on there and there is no garnet. Most of the porphyroblasts are of albite. And we have proposed using some Fahrenheit the pressure conditions, and we can see that at least one group of rocks of the metasedimentaries reach pressures that goes maybe near to the 4.5 kilobars. And we also made some studies on the amphibole facies on the metavolcanic rocks, and we can see that it is in accordance with 5 kilobars, but some samples could reach even close to the 7 kilobars. Also with the temperature, we performed some calculations with the content of chloride, and we can see the metavolcanic rocks are those ones which reach the lowest temperature, while the metasedimentary rocks, they reach even close to the 400. So we are in accordance with the, more or less in accordance with the results from the graphite. And we can see that at least on the metasediments, we have two groups of low to medium pressure and high pressure. So we are interpreting that we have at least two periods of metamorphism. So the Granjeno Schist has, or the deposition of the protoliths of the Granjeno Schist took in a very long time, from the Devonian nearly to the age of the Metamorphism, which was 399. Sorry, it was 300 million years. And we have proposed that the deposition where it took place on basins, pull-apart basins, really close to the microcontinent named Oaxaca, which is represented by the Novillo Gneiss, and also to the periphery of the Gondwana. Through the late Ordovician, it is proposed that a subduction zone was established, and during this time, the position continued, but tectonostratigraphically, we are moving around, and the Granjeno Schist is moving together with Oaxaca most of the time and receiving still a more input of the Oaxaca. Also here we propose that it is possible that the metamorphism start. So during the Paleozoic and Permian age, which is the metamorphic age calculated on the metavolcanic rocks on the muscovite, we can say that we have an evolution which goes from the subgreen schist facies to the green schist facies formation, and then we have this retrograde through the collisional zone between the final part of North America and Gondwana. So this part in Mexico is representing the one of the continuation of the closure going from North America to Gondwana through the south. But the difference with other proposition that was made is that most of the history of the Granjeno Schist and Oaxaca is linked to Gondwana and not to the Laurentia border. So we can conclude that the highest temperature reached was 430 degrees, which indicates a hydroid metamorphism, and according to the mineralogy and the other mineral phases, we can say that at least it has a regional retrograde final stage during the closure of Pangea. So understanding this unit allows us to propose that contains the precursor rocks of continental affinity and an ocean plate stratigraphy package that was proximal to a continent. So thank you very much, and I'm quite open to questions and suggestions.
Thanks, Sonia, that was really interesting, and loved those field photos at the beginning. Just one quick question from Bernardo, who is asking, there's no garnet in the rocks, but was there any biotite?
It is biotite, yes.
And then following up to that, did you analyze the bulk composition of the peelites? Are they more magnesium than the average peelite?
Yes, we analyze them, but they are not so rich on magnesium. They are more with an affinity of the upper continental crust, so they are quite felsic.